Hello viewers, I am Dr. N. Srinivasan from the Department of Physics, Kongu Engineering College. My topic for the day is semiconductors. So before going to the topic, you know very well about materials are classified into conductors, semiconductors and insulators. In addition with that, you can add superconductors also. So conductors are low resistive materials, insulators are high resistive materials. Superconductors are zero resistive materials. So in between conductors and insulators, we have a type of material called semiconductors. Semiconductors are the materials with lesser band gap. So now you just try to understand band gap is the energy difference between conduction energy level to valence energy level. We have two kinds of bands. One is called a conduction band, another one is called a valence band. The energy difference between conduction band and valence band is called a band gap or energy gap. So semiconductors are the materials with the lesser band gap. Conductors, they overlap. Conduction band and valence band will be overlapped. For insulator, the energy difference between conduction band and valence band will be large, so more than 5 electron volt. So for the semiconductor, the energy difference, that band gap value is less than 3 electron volt. So silicon is an excellent material which is a semiconductor. Germanium is also a semiconductor. So that we have so many semiconductors are available. But silicon is a widely used semiconducting material. So IC or any chip that is made up of silicon. So I hope usage of silicon is very much wide. So that if you talk about semiconductor, then you have to say about silicon. Very good. So semiconductors, they normally behave like insulators at room temperature. When the temperature is increased, then electrical conductivity of the material also increased. So at room temperature, they behave like an insulator. When temperature is increased, the electrical conductivity of the material is also increased. So normally they exhibit a negative temperature coefficient of resistance. That means resistance and temperature are inversely proportional. That is the important property of a semiconductor. So the semiconductor can be classified into two basically, that is intrinsic semiconductor and extrinsic semiconductor. So intrinsic semiconductor is a pure semiconductor. So silicon is an intrinsic semiconductor. So they are widely used. Another type of semiconductor is called extrinsic semiconductor. So extrinsic semiconductor is an impure semiconductor. So in extrinsic semiconductor we have two types. One is called N-type semiconductor. Another one is called P-type semiconductor. So because of addition of impurity, extrinsic semiconductors in the application sites, they have very good applications. So the process of adding impurity with the semiconductor is called doping. So doping is the process of addition of impurity with the semiconductor. So we have two different dopants. One is called pentavalent impurity, another one is called trivalent impurity. So when you add a pentavalent impurity like phosphorus into the intrinsic semiconductor, then that will become N-type semiconductor. So in N-type semiconductor, majority charge carriers are electrons because donor impurity is added. So donor impurity has 5 valence electrons. Acceptor impurity has 3 valence electrons. So one extra electron is donated to the semiconductor because semiconductor has 4 valence electrons. So that fifth electron will be donated to the semiconductor. So that majority charge carriers, number of free electrons will be more. Majority charge carriers are electrons in n-type semiconductor. In p-type semiconductor, acceptor impurity is added. So acceptor impurity has 3 valence electrons, semiconductor has 4 valence electrons, so that one electron is accepted by the impurity, so that it is called acceptor impurity. So in p-type semiconductor, majority charge carriers are holes. Then automatically minority charge carriers are electrons. So based on your suitability, your nature of application, you can use the intrinsic semiconductor or n-type semiconductor or p-type semiconductor. So in addition with that intrinsic and extrinsic, we have elemental and compound semiconductors. So elemental semiconductors, the name itself, they are made up of a single element. So silicon is an elemental semiconductor. Then you see compound semiconductors, they have 2 or more elements. Compound a material with 2 or more element. So compound semiconductors, they have 2 different elements, 2 or more elements. Normally they are made up of 2 elements. Gallium arsenide is a compound semiconductor. So normally they are made up of with a group 2 elements and group 6 element, or group 3 element and group 5 element. So 2 different combinations are possible. So generally gallium arsenide is important compound semiconductor. So in addition with that these 2 classifications, we can go for direct bandgap semiconductors and indirect bandgap semiconductors. So direct bandgap semiconductors, that means recombination of electron and hole will takes place directly. In indirect bandgap semiconductors, recombination of electron and holes takes place indirectly through traps. So trapping is a mechanism in which electron hole recombination takes place in an indirect bandgap semiconductor. So today we have discussed about basic informations on semiconductor. So semiconductor is an important material which is mostly used in the electronics industry. So semiconductor lies in between conductor and insulator. So when temperature is increased, this conductivity of the material will be increased. So it can be classified into intrinsic, extrinsic. In extrinsic, N type and P type. Another way of classifying elemental and compound semiconductors. Based on the number of elements, we can classify semiconductors into elemental and compound semiconductor. Then another method of classification is direct bandgap and indirect bandgap. This classification is based on the electron hole recombination mechanism. So important property of the semiconductor is negative temperature coefficient of resistance. So this property brings unlimited applications to semiconducting materials. So I hope today you are able to understand about semiconductor. It's a lesser bandgap material and different types of semiconductors. Thank you.